So earlier we saw some layer 2 securities like MAC flooding attack can be mitigated by setting the number of MAC address that can be learned on a port. We call that feature as port security. And also we learned VLAN hopping attack can be prevented by simply configuring switchboard mode access. We learned the AAA using TACAX radius and local authentication methods. We learned .1x. Now we're going to learn a few more things like VLAN ACL. Within a VLAN, you can deny conversation between two devices within a VLAN. Usually, all members are allowed to talk, but by writing VLAN ACL, you can deny someone talking if you want it to happen. It's possible for us to prevent two devices in same VLAN deny communication. On a switch level, you can do this. You no need to do it on a router. Usually in router you cannot do. Why? These devices belong to same VLAN, so they are not going to pass through router. Router ACL or RACL, which is on the top, they only can stop traffic that pass through. If you deny, then routers are going to stop. But members of same VLAN, they don't pass through router, but they do pass through a switch. Switch will check the destination MAC address, and when it is about to move, the VLAN ACL will be there on the TCAMs, stopping them to move, denying them to move. We don't exit on the interface where the other member with whom the conversation is denied. To configure VLAN ACL, this is the command. Please, it's focus. It's easy. I'm not going to do this now. I'll do it a bit later. I want to finish this. VLAN access map and give any name. This is an optional one. And then match the IP address, the source and destination IP address of the computers which are in same VLAN. And then you take the action, whether to drop it or forward it or redirect it through some other port or send it through a port channel. If you want to deny, the action is going to be dropped. At last, go to the global configuration mode and say VLAN filter and give a name. No, sorry. Call the name that is given earlier, and then give the VLAN number or numbers. Usually number, VLAN 10. Boom. There is no sample configuration, but when I do, you will understand. VLAN filter, call the access map that you created. That's the name comes here. And then for which VLAN you want to do this? For which VLAN is nowhere mentioned, right? Nowhere mentioned. This is the place you mention it. This is also called as MAC ACL or layer 2 ACL. There is also one more called MAC ACL itself. But this also filters based on the MAC address. The members of same VLAN, of course, they get filtered based on MAC address. But there is also one more ACL called MAC ACL, which is not mentioned in this presentation anywhere. The next topic is private VLAN. This is Cisco's feature called private VLAN. See, VLAN itself is an isolation. Itself is it's a kind of private. VLAN helps to have different broadcast group. One broadcast group is private from the other. VLAN itself sounds like a private. Then what is this private VLAN? Before we go into that, usually in interviews, when someone asks what is private VLAN, everyone will say VLAN number 1. No, VLAN number 1 is a default VLAN. Because we never heard about private VLAN, we think that VLAN number 1 as an answer for the question, what is private VLAN? Private VLAN is a separate concept. It's not default VLAN. By default, we will have VLAN number 1 on all the switches. But there's a big difference between private VLAN and default VLAN. There is also one more VLAN called native VLAN. For that also, mostly people will say native VLAN is VLAN number 1. See, answer is right partially. For native VLAN, answer is right partially. Native VLAN, actually answer for native VLAN is 1 only. But all these 3 are not same. Private VLAN is different. Native VLAN is different. And you know what is default VLAN? By default it is that, so it is default VLAN. By default, you have only this VLAN. So for native VLAN also by default they use that same VLAN because there is no other VLAN to use as a native VLAN. But they're not the same. VLAN number is same, VLAN is same, but concept is not same. Default VLAN cannot be any other number other than 1. But native VLAN can be changed later to any number. By default, you don't have any other VLAN, so VLAN 1 is used as a native VLAN. But when you have some VLANs on switch like 10, 20, 30, 40, 50, I can make 80 as a VLAN native VLAN. But you cannot change number 1 from the default VLAN. Default VLAN is always number 1. Native VLAN, initially it will be 1, but you can change it to anything that you like. For that, you should know why I should change. What is native VLAN? You should know what is native VLAN. Only then you will know why to change. That's one thing. Thirdly, private VLAN. Private VLAN is VLAN within VLAN. Private VLAN is VLAN within VLAN. When we have VLAN, all members will talk, but you have some policy like within a VLAN, let's say you have 200 computers. within a VLAN number, let's say 500. How many pieces you got? You got 200 PC. Now this 200, though they are in VLAN 500, even though this 200 computers belong to same broadcast group, though you want to put them in same broadcast group, you don't want some of them to communicate each other. Let's say out of 200, 75 computers you want to be a separate group in that 200. So you can create a sub VLAN like this and say this VLAN is a community VLAN, meaning members of this 201 can talk each other, meaning the 75 members can talk each other. They are not supposed to talk to any other members, like another 125 members cannot talk to this members. Now you may have another 50 computer. Between them, among them, you don't want them to talk, nor to this group member. Let's say that's your policy. I don't want this 50 people to talk each other. Also, to talk to anyone. All these 50 need to be an individual, isolated, though they are in same VLAN. Then what you can do is, for that 50 people, you can set a VLAN, for example, 200, and say isolated. Even though they belong to same VLAN, they cannot talk each other. They will be isolated. See? So, private VLAN is a Cisco's concept, I told you. Other vendors don't know this.
So we can do a separate VLANs. Why do we need to do this?
That's a good question. When you are not going to allow, mute please, when you are not going to allow these members, I said 75 members, not to talk to others, why can't you put the 75 members in a separate VLAN? That's the question. Yeah, answer is, you see, we do not want them to be in a different broadcast domain as per the policy. As for the policy, there is some expectation. There is some policy in your company which is forcing you to put all of those 200 computers in a single VLAN. Maybe based on the VLAN ID, there is some other policy in routing or somewhere else. So if you break this, guys, and that policy won't work. So there is some dependency with that VLAN ID. I gave you example 500. So all the members of 500, they have some common policy outside the switch somewhere. So if you break them and put them in different VLANs, like individual VLANs, like 205, 255, something like that, the policy that is tied to 500 cannot be achieved. So under 500, when you create secondary VLAN 205 and secondary VLAN 255, they all still belong to same VLAN 500. So the traffic going from this VLAN and 255 will get the policy that is tied to 500 on the top somewhere. So you want all these computers to be in same VLAN. at the same time in a different VLAN. Same VLAN for the outsiders, different VLAN within this LAN. In that case, we create secondary VLANs. All the traffic going out from the secondary VLAN via the primary VLAN will be identified only with a VLAN primary, not by the VLAN secondary. So here we have seen a mode called community, a mode called isolate. Members of communities can talk. You can have more than one community. You can have more than one community. So I can have, say for example, under VLAN primary 500, I can have a isolate VLAN 200, community VLAN 201, another community VLAN 202, another community VLAN 203. Under this 50 computers, under this 50 personal computers, under this 50 personal computers, and under this another 50 personal computers. So totally 200 computers I said. Now members of these this community, this is community, this is community, this is also community, this is isolate. Members of this community will not talk to isolate member nor the other communities. Members of this community will not talk to this community nor to the isolate nor to the other community. Members of this community will talk each other. They will also talk to Prometheus, which is the third mode. Prometheus port. Primary VLAN and Prometheus port are same. Primary VLAN members alone can be a Prometheus port. Prometheus port is a port that talks to all isolate members and all community members. All isolate can talk to Prometheus. All isolate can talk to Prometheus. All community can talk to Prometheus. Community can talk to Prometheus. Prometheus can talk to community. Isolate everyone. But a community cannot talk to another community member. An isolate member cannot talk to another isolate nor to the other communities. But isolate members can talk to community. The isolate members can talk to Prometheus. That is the way that they go out and identify themselves as VLAN 500 instead of VLAN 200. You see the Prometheus port, it is connected to a router. Because if you want to talk between different community, then your router should permit. You need to go via permission. So you see here, private VLAN port types. Isolated Prometheus community. Isolated communicates only with Prometheus port. What is Prometheus? Communicates with all ports. What is community? Communicates with other members of same community and also to all Prometheus ports. Right, the configuration part I do not want to go inside now. We will only focus on theory as I said earlier. Later on we will do the labs. Do you have any question on this?
Community can talk with other communities.
No. Members of same community can talk to each other. Here they have not mentioned it. Communicates with other members of same community. See, if they can talk to other community, then you don't need to put them in another community. Hmm? If they can talk to another community, why you need to put them in different community? Hmm? Communicates with other members of same community and also with all promiscuous food. Alright. Again, this is a Cisco's idea. You will not find this topic anywhere else. Let us go to next concept called VLAN spoofing. Spoofing attack. Simply spoofing attack. Spoofing means I already told you. Spoofing is pretending to be someone, proving as someone. Or making others to believe that you are someone, not you. Yeah. Spoofing. Spoofing. We will be very hungry, want to eat the full food in the front, but just for the sake of others, we just pick one cutleries and spoons, and then we pretend as if we are allergic to food, and we take very small, little. That is spoof life, pretending life, acting, not the real. Spoof. They will pretend all these things in the cafeteria, but when in the workplace they behave all indecent way. Only in the food they will show their decency. Corporate peoples. The work area they will pull others' leg. They'll try to push them in a deep pit. Others in a deep pit. I don't understand this anyway. All spoofed people acting. They don't want others to come up in life. But they only in the cafeteria they pretend as if I don't like food. Means I don't eat like a pig. I'm very decent. But inside the office they behave like pig only. Grabbing everyone's food, not allowing others to grow. So most of our human community is spoofed, not real. Spoofing, you understood very well now. You see, this is another spoof. The original DHCP is here, and there is a client. There are many clients, or one or two, many clients, whatever. The client needs an IP address. So DHCP server supposed to provide an IP address, but there is a rogue DHCP server providing address. And client believes that I'm getting from genuine, but it is actually what? Rogue, giving an IP address. Rogue DHCP provides an address, but client believes that it is receiving from genuine. This is what called a spoofing. What do you want to be in next 5 years? And when you say something, um, they pretend as if they appreciate you. But in reality, why this fellow has come here? If he comes and two people should go out, He's more skilled. Why did he come here? That is what will be going inside his mind. And they never help you to achieve that. Simply they will ask that question, how will you find yourself in next 10 years? Why you want that? In what way you're going to help me in growing? Why you pretend? Why you ask this question? They just pretend as if they take care of your future. When you go for an interview, HR ask always this question, no? Where do you find yourself in next 10 years? As if this guy is going to feed you, provide you car, provide you a coatress, provide everything for you. Nothing. Fooling. Especially in India, at least in abroad, you get some medical insurance, this and that. In India, nothing. Fooling. Rogue caretakers, not real caretakers. They want to take the place of God there. See, we are God. We give you work. You work for us. Forget about the real God. Don't thank Him. Thank us. Be faithful to us. We'll give you beer every evening, Friday, or every Saturday. We'll give you beer, 1 cup of beer. This is IT today. Spoofing God. Spoofing. You understood very well, right? Now, how is this possible in DHCP? DHCP spoofing attack. See, for that you need to understand how DHCP works. When a client is on, means who is a client? The one who wants to receive an IP address from server is a client. As soon as you on this client computer, it will send a layer 2 broadcast looking for a DHCP server, not asking for an IP address, looking for a DHCP server. So the broadcast request, the layer 2 broadcast, see, it cannot be a layer 3. Why, You don't have an IP address. How can you do layer 3 communication? You need an IP address. So you are in search of a DHCP server so that when you find the DHCP server, you can send a request asking IP address. So the first what happens is discover. The discover is a layer 2 broadcast. Discover packet. What it is trying to discover? A DHCP server. So client is sending a layer 2 broadcast. Client is sending the discover packet. Because it's a layer 2 broadcast, there are chances, it will always be sent everywhere. So, including the rogue DHCP, the discover packet is received. Because it's a layer 2 broadcast. Everyone in the same VLAN or everyone in the same switch, if there is no VLAN, then all will be in same VLAN. So all members of that default VLAN 1, because the client is in default VLAN 1, all the members in that same broadcast domain is going to receive a discover packet sent by the client. What is discover packet? Asking, hey, are you a DHCP server? Are you a DHCP server? Many computers will receive it, but they will not respond because they are not DHCP server. But here is a rogue guy who is pretending to be a DHCP, wants to respond. And legitimate is also going to respond. And this is a unicast layer 2 packet. How it is a unicast? The reply is going to go to the MAC address of the client from where the discover packet came. Now you see this rogue comes first, assume, with offer. We call it as offer packet. Offer packet before the legitimate reaches the client, before the legitimate reaches, the rogue reaches the client and say, hey, come on, I can help you. Tell me what I should do. I'm a DHCP server. Now the client is learning from both DHCP server. Now client has to decide whether to choose the first one or the second one. Usually the clients choose the first one. Whoever responded first. Unfortunately here the rogue has responded first. Rogue has responded first before the legitimate. How? Because legitimate is a bit far away from the client. Rogue is very near. Rogue is very near. And legitimate is a little bit far. Why did you keep or why did you allow legitimate to be far? That's the problem. You should have kept legitimate near so that rogue will be away. Anyway, here the problem is legitimate server is very far. So it took some time for responding. It has to come through various switches. Rogue responded faster. Now the client picks the rogue offer. Rogue has offered saying, I'm a DHCP server, this is my MAC address, now tell me, you can ask me whatever you want. Client says, okay, I choose the first one, but first one is happen to be what? A rogue here. Next. So client chooses the rogue without knowing it's a rogue, and it sends a request asking for IP. For which the rogue is going to provide an acknowledgement, which is the last packet, in which IP address will be provided by the rogue. See, DHCP not only provides IP address, DHCP can provide gateway address also. So if it is attacker will give his router's address as a gateway. So all the conversation from this client is now going to go through the attacker's network. You see, the client may not know that we are under attack. We are going through the attacker network. Client may not know it because for client he wants to go online. He can go online now, but he's not aware that I'm going through attacker's network. So the middle guy, the attacker, can gain access to all the data now that is going from this client and coming to this client. How can you prevent this? We can prevent this man in the middle attack by setting trust. We need to go to this port and say trust, 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 trust. Trust for what? Trust for DHCP. Trust for DHCP. Trust for DHCP. Trust for DHCP. And also, when you say, okay, fine, when you say these trunk ports as trusted ports, all the other ports, all the other ports, meaning the ports that are connected to this computer, the ports that are connected to this computer, the ports that are connected in here, all these ports are untrusted, including this one. That is simple, no? Very simple. So when an untrusted port tries to provide offer, this port will go into inconsistency state, meaning the port will go for shutdown for few minutes, actually 5 minutes. Inconsistency state. I'll talk about error disabled recovery later. So when you enable error disabled recovery, it will go for inconsistency state for 5 minutes. After 5 minutes, it will come back again. Anytime this untrusted port send offer, which is not supposed to send. Who's supposed to send the offer? Only a legitimate DHCP server. But if a computer sends, which is not considered as a legitimate, if a computer like this rogue device tries to send an offer, I told you the DHCP is 4 packets: discover, offer, and then only request, and then only acknowledgement. So if someone says, I'm a DHCP server on an untrusted port, that port is going to be shunned for some time, will be going to inconsistency state. This is how we can prevent a rogue responding to a DHCP discover message. You see how easy it is? Even the client is interested. You cannot send an offer. No one can send an offer. The offer can be sent only via the trusted ports. So the name for this, making trust and untrusted, is called a snooping. Snooping is the medicine for spoofing. For spoofing, what is the medicine? Snooping. How do we prevent spoofing? Educate people what is real good and real bad. All the glitters are not shine or not gold. You need to rightly divide the real gold and the shiny, tricky, false gold. Teach them to choose the good. Teach them which is trusted and which is untrusted, which is reliable and unreliable, which is real future, which is fake future. So, untrusted and trusted, the differentiation can protect. Which one to trust, which one should not be trusted, which is really reliable, which is fake reliable. When we identify, we can protect ourselves from spoofs. We call that process as snooping. DHCP snooping allows the configuration of port as trusted or untrusted. Untrusted ports cannot process replies. An untrusted port cannot process replies. If a reply comes for a DHCP conversation, untrusted port is not going to allow the reply to get inside. It won't process. This is how you prevent the DHCP spoofing attack. Configure DHCP snooping on the uplinks to a DHCP server. So meaning you need to make these ports as trusted. That's all. That is what meaning configure DHCP snooping. When you make all those ports towards the legitimate server as a trusted, rest all the ports will be untrusted. Rest all ports will be untrusted. You don't need to focus on untrusted. Focus on what is trusted. Only focus on what is trusted and speak only those trusted. No need to focus on untrusted, explaining the untrusted things more. Trusted, 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 then you are safe. Configure DHCP snooping on the uplink to a DHCP server, which means all those ports towards the legitimate is configured as trusted. All the rest is automatically going to be untrusted by the client or by the switch. Do not configure DHCP snooping on the client port. Means don't make all these client ports as trusted. See, according to this network, this is also a client. This can also get an IP address, meaning don't make those computer connected port as uh, a trusted port. That's the meaning of this. Even the client port should be untrusted only. See, the job of client is sending only discover packet and request packet. Can a client send an offer? No. If it sends an offer, then he is a rogue DHCP. Only a DHCP can send an offer and acknowledgement. A client can send only a discover and request. So you need to leave it as untrusted. All untrusted ports can only send these two things, whereas trusted port can send and receive discover, offer, request, and acknowledgement. Only a trusted port can send and receive all these four, but an untrusted can send only discover and request. Sending, but it can receive all. If someone sends a discover packet, it will come. If DHCP server responds with an offer, it will come. On an untrusted port, it will come. An untrusted port can send a request. An untrusted port can receive an IP address acknowledgement. Fine. So we got this. And this is how it is configured. You see, we go and say trust only on those port on the path towards the legitimate DHCP. This you need to enable snooping in the global mode. When you say IP DHCP snooping, all the ports become untrusted, and you go only to those ports which you want to trust, then your DHCP is over. And this is again IP DHCP. This is also global. For which VLAN you are enabling this have to be mentioned. This is an optional one. This need to be done in some switches because option 82 is used for relay agent. I'll talk about this later when we in DHCP topic. You no need to worry about this command now. So this is important to enable the feature. This is to enable it on particular for particular VLAN, and this is to make those ports trusted that are legitimate, that are pointing towards a legitimate server. The command show IP DHCP snooping will show you whether DHCP snooping is enabled, if it is enabled, on which all interface it is enabled, and what all VLANs it is enabled. See, DHCP snooping is enabled on only these two are trusted. This is not trusted. This is default. By default, DHCP packets 20 per second is allowed. See, if more DHCP packets are coming, then there are more rogue DHCP. For one DHCP, this is the maximum number of packets. That's why they have set it as 20. This command will give you an option to increase or decrease the number of packets per second. What packet? DHCP related packet. IP source guard. IP source guard is to check whether the packet is coming from the genuine source. It's the same table that we are going to use. See, through DHCP, everyone is getting IP address, right? So DHCP is using these switches to provide IP address. So this switch knows what IP address is given to this guy. Let's say this guy has received 10.1.1.10. But if he is telling lie, I am 10.1.1.9, then switch will say you are a liar. It knows the source address supposed to be 10.1.1.10, but he is telling a lie. He is trying to lie so that he can spoof the layer 3 address. That's what IP source guard does. So for IP source guard, you need to enable DHCP snooping. Only then IP source guard is possible. This is the command to enable IP source guard. It will verify the source address. Next is ARP spoofing. This is also a man in the middle attack. ARP will also send a layer 2 broadcast. ARP is sending, hey, who is this MAC address? What is the MAC address for 10.1.1.1? See, A wants to communicate to C, but he don't know the MAC address of C. So it is sending a layer 2 broadcast asking who is that 10.1.1.1. That's the ARP request. The legitimate reply is CCC, but before the legitimate replies, this guy in the middle, he says, this is my MAC address. I am 10.1.1.1, but he's not 10.1.1.1. He's 10.1.1.3. But this fellow is spoofing. Before C responds, B quickly says, it's me, BBB. So A thinks that BBB is the MAC address for 10.1.1.1. But what is the real MAC address? CCC. Switch don't check for the IP address because you have not enabled the source guard. If you enable source guard, then it would have found it, but you didn't enable source guard. So switch forwarded the ARP reply. A now thinks that MAC address of 10.1.1.1 is BBB. So whenever a computer sends packet to 10.1.1.1, it will put the packet to the MAC address BBB. Packet comes with MAC address BBB will be forwarded to this guy. So he wants to see what this A and C is talking. That's why to C also he said, I am BBB, my MAC address is BBB, I am 10.1.1.2. See? But he's not 10.1.1.2. The 10.1.1.2 is the real genuine A. So B has played a cheating game between A and C. B made A to believe that he is C. B made C to believe that he is A. So A, whenever it's sent to C, it is sending to B. C, whenever it is sending to A, it is sending to B. And B is just, redistributing it by seeing what they are talking. So this guy gets a copy of all the packets and exchanging it in between them. So he can use those information, those data to spoil the company or whatever. B knows the secret conversation or whatever the conversation between A and C. B is spying. B is spying between A and C. All right. So Dynamic ARP inspection is also same. For that, you need to enable DHCP snooping. If DHCP snooping is enabled, then you enable ARP inspection. Now, on all the untrusted ports, it will inspect the IP address and MAC address with the DHCP table. See, every switch knows what MAC address has got what IP address, to which MAC address DHCP gave IP address, what IP address. So if someone is spoofing, if someone says my MAC address is this, it will check against the table which is created using DHCP request and response whether the MAC address and IP address matches. If it matches, only then it will forward the packet. If not, it will put them into inconsistency state. Right. So that's about ARP inspection, dynamic ARP inspection. Um, Same like DHCP snooping, but again, I'm telling you, for ARP inspection, you need DHCP snooping already enabled. Um, Likewise, for source guard, also you need to have DHCP snooping enabled. So in this chapter, we learned about spoof attacks. In the next chapter, we are going to focus on STP-related attacks, which we'll do in the next class.